What role do synapses play in neurodegenerative disorders like Parkinson's? Imagine the brain as a busy city where neurons are the residents communicating through tiny bridges called synapses. These synapses are essential for sending messages that control everything from movement to mood. In Parkinson's disease, these tiny bridges start to malfunction long before the neurons themselves die. This early trouble at the synapse level is a key part of how the disease develops. In Parkinson's, the problem often begins with the presynaptic terminals, where neurons releases chemicals called neurotransmitters. The main neurotransmitter affected is dopamine, which helps regulate movement. When synapses don't work properly, dopamine can't be released or received efficiently. This disrupts the normal flow of signals in the brain's movement pathways, leading to the characteristic tremors, stiffness, and slow movements seen in Parkinson's. A major factor behind synaptic problems in Parkinson's involves a protein called alpha-synuclein. Normally, alpha-synuclein helps keep synapses functioning smoothly. But in Parkinson's, this protein starts to clump together into abnormal aggregates. These clumps interfere with how synaptic vesicles, tiny containers that store neurotransmitters, are trafficked and released. As a result, dopamine releases drops, and communication between neurons weakens. Research shows that these synaptic issues happen early, even before neurons start to die. This means that the initial symptoms of Parkinson's, like subtle movement changes, may be linked to these synaptic disruptions. When synapses fail, the signals that tell muscles how to move become weaker, causing the motor symptoms that are so common in the disease. It's not just dopamine that gets affected. Other neurotransmitters like gamma-aminobutyric acid, which helps calm brain activity, also show changes. These disruptions can throw off the balance of neural circuits, making symptoms worse over time. Additionally, faulty synaptic function can trigger inflammation in the brain, which may speed up neuron loss. Understanding the role of synapses in Parkinson's opens up new possibilities for treatment. Scientists are exploring ways to protect or restore synaptic health, aiming to slow down or even halt disease progression. For example, some research focuses on preventing alpha-synuclein from clumping or improving how synapses communicate. In summary, synapses are the critical communication hubs in our brain. When they start to malfunction in Parkinson's disease, the entire system begins to break down. This disruption in neuronal messaging, especially involving dopamine, is what leads to the movement and other symptoms we see. Recognizing these early synaptic changes offers hope for developing treatments that could intervene before irreversible neuron loss occurs. Always remember, if you or someone you know is affected by Parkinson's, consulting healthcare professionals is essential for personalized care and the latest treatment options.